It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe.
Mercury, the tiny planet closest to the Sun, holds vast, hidden mysteries. Despite its small size and intense heat, it has confounded scientists for centuries. However, space probes have now revealed some truly surprising secrets. They've even found diamonds on this scorching world. And that's just the tip of the iceberg. The planet's interior is an enigma. It's too large and too unusual. What makes it stand apart from other planets, and what other secrets might it hold? As the smallest planet in our solar system, Mercury has fascinated astronomers and space enthusiasts for generations. For years, its surface was shrouded in mystery, until space exploration made great leaps. The journey to uncover Mercury's secrets began with NASA's Mariner 10 mission in 1973, followed by the Messenger probe in 2004. Mariner 10, the first spacecraft to visit Mercury, provided us with our first close-up look at this elusive planet. During its flybys, it captured images of a surface pockmarked with craters and strange ridges, resembling our moon. The mission revealed Mercury's battered exterior, an unexpectedly strong magnetic field, and a surprisingly large core, challenging scientists' earlier assumptions about the planet's makeup. 3 decades later, Messenger, Mercury's surface, space environment, geochemistry, and ranging, expanded our understanding even further. Unlike Mariner 10, Messenger entered Mercury's orbit, allowing for a much more thorough exploration. During its mission, Messenger captured over 200,000 images, offering unprecedented detail of Mercury's surface. One of its most intriguing discoveries was the unusually high levels of calcium and magnesium on the planet's darker side. This raised important questions about the processes that could lead to such high concentrations. The mission also revealed that Mercury's magnetic field is unusually strong in its northern regions, an unexpected finding when compared to other planets. These discoveries prompted scientists to reconsider their initial ideas about Mercury's internal structure and formation. On most planets, like Earth, magnetic fields are generated by the movement of liquid iron in the core. However, Mercury's unique internal composition produces different magnetic behavior. But what truly sets Mercury's terrain apart, it's not just the craters and ridges, it's the extreme conditions on its surface. During the day, temperatures on Mercury can soar to a blistering 433 degrees Celsius, hot enough to melt lead. At night, they drop drastically to -92 degrees Celsius. This extreme temperature variation occurs because Mercury has a thin exosphere that does little to regulate or retain heat. Despite these harsh conditions, recent studies have uncovered surprising features on Mercury's surface. In 2012, Messenger data provided evidence of volcanic activity on Mercury, including pyroclastic deposits from explosive volcanism. This discovery challenged the long-standing belief that Mercury was geologically inactive. Even more fascinating, in 2020, scientists confirmed the presence of water ice in some of Mercury's polar craters. These permanently shadowed regions are cold enough to preserve water ice even on a planet so close to the Sun. This discovery has raised intriguing questions about the possibility of simple life forms on Mercury. Could extremophiles, similar to those found in Earth's harshest environments, be thriving in the planet's icy refuges? The latest mission to Mercury, Bepi-Colombo, launched in 2018 as a collaboration between the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive in 2025. This mission is expected to provide even more detailed insights into Mercury's surface, its chemical makeup, and geological history. From its unexpectedly strong magnetic field to the discovery of water ice, Mercury continues to astonish. But what we're about to explore next will really make you take a second look. How does a planet so close to the Sun have a year shorter than its day? When we think of planets, we typically picture them spinning once on their axis each day and orbiting the Sun over the course of a year. However, Mercury defies this norm in a fascinating way. On this small sun-baked planet, a year is actually shorter than a day. Here's how it works. Mercury takes just 88 Earth days to complete one orbit around the Sun. But here's where it gets really fascinating. A single day on Mercury, one full rotation on its axis, takes an astounding 176 Earth days. This means that a year on Mercury is only half the length of a day. This unique scenario leads to some bizarre effects. If you were standing on Mercury's surface, you'd witness the sun rise, slowly grow larger in the sky, and then appear to stop, move backward for a time, and then resume its original motion. This odd phenomenon happens because Mercury's slow rotation cannot keep up with its rapid orbit. But why does Mercury rotate so slowly? Scientists believe it's the result of tidal locking. Over billions of years, the sun's gravitational force has gradually slowed Mercury's rotation. Unlike Earth's moon, which is completely tidally locked, Mercury experiences a 3D2 spin orbit resonance, meaning it completes 3 rotations for every 2 orbits around the sun. This results in an extreme day-night cycle on Mercury's surface. The side facing the sun endures intense heat for months, while the night side remains in freezing darkness for an equally long stretch. This leads to some of the most drastic temperature fluctuations in the solar system. As for Mercury's atmosphere, it has a very thin exosphere which is constantly being lost to space and replenished through various processes. The solar wind, radioactive decay, and micrometeorite impacts all play a role in maintaining this fragile exosphere. In 2020, data from the Messenger spacecraft revealed a surprising discovery. Mercury's exosphere contains more water vapor than previously believed. This water vapor is thought to form when hydrogen from the solar wind interacts with oxygen in the rocks of Mercury's surface. Another intriguing feature of Mercury's short year and long day is its impact on the planet's magnetic field. Despite its small size and slow rotation, Mercury has a global magnetic field, which came as a surprise to scientists when it was first discovered. Recent research indicates that this magnetic field is generated by a unique dynamo effect within Mercury's liquid metal core, influenced by the planet's unusual orbital and rotational properties. Although much weaker than Earth's, Mercury's magnetic field is essential in shielding its surface from the harsh solar wind. Without it, the solar wind would rapidly strip away Mercury's already minimal atmosphere. Mercury's rapid orbit and slow rotation create fascinating opportunities for observation. On certain points of its surface, known as hot poles, the sun appears to remain stationary in the sky at specific times. These areas experience the planet's most extreme heat. Meanwhile, near Mercury's poles, there are regions that never see sunlight. These permanently shadowed areas have been found to contain water ice. But how can ice survive on a planet so close to the sun? The answer lies in Mercury's unusual orbit and rotation. The craters at its poles, which are always in shadow, remain intensely cold, even as surrounding areas endure the sun's scorching heat. This finding has prompted scientists to ask, could other volatile substances, such as organic compounds, be preserved in Mercury's cold traps? The planet's short year and long day also influence how we study it. Since Mercury orbits the sun rapidly, it's difficult for spacecraft to reach it. They must perform intricate maneuvers involving multiple flybys of Venus and Mercury itself to slow down enough to enter orbit. The Bepi-Colombo mission, currently en route to Mercury, will utilize these gravitational assists to gradually modify its speed and course. Launched in 2018, the spacecraft is scheduled to enter Mercury's orbit in 2025 after completing 9 planetary flybys. Upon reaching orbit, Bepi-Colombo will confront another challenge tied to Mercury's unusual day-night cycle. The spacecraft will need to manage its exposure to the intense heat on Mercury's day side while also ensuring power during the long, frigid nights. Maintaining this balance is critical for the mission's success and underscores the extreme conditions resulting from Mercury's distinctive rotation and orbit. Recent computer simulations have shed light on how Mercury arrived at its current rotation rate. These models indicate that Mercury may have once rotated much more rapidly, but was slowed down over time by the combined forces of the sun's gravity and collisions with large asteroids or comets. This research not only sheds light on Mercury's past, but also offers insights into the evolution of other planets in the solar system. As we continue our exploration of Mercury, new questions emerge. How does the planet's core stay partially liquid despite the extreme cold and long nights? How does Mercury's unique orbit influence its geological features? These unanswered questions remind us that even within our own solar system, there are still many mysteries to uncover. Mercury's distinct traits challenge our understanding of planetary formation and evolution, urging us to rethink existing theories and consider new possibilities. So, what other surprising secrets might Mercury be concealing beneath its cratered surface? As the smallest planet in our solar system, Mercury holds an astonishing number of secrets in its compact form. Despite its size, Mercury continues to puzzle scientists with its peculiarities and unexpected features. One of its most fascinating mysteries is its unusually large core. Dr. Nancy Chabot, a planetary scientist at the Johns Hopkins Applied Physics Laboratory, led a study that revealed Mercury's core makes up roughly 85% of the planet's total volume. This is significantly larger than Earth's core, which only accounts for about 15% of our planet's volume. But why does Mercury have such a massive core? One theory suggests that Mercury may have once been a much larger planet that lost most of its outer layers in a massive collision early in the solar system's history. This idea, known as the hit-and-run scenario, was proposed by Dr. Eric Asfog from the University of Arizona. According to this theory, a large planetesimal might have struck Mercury, stripping away much of its mantle and crust, leaving behind the iron-rich core we see today. Another intense secret of Mercury is its unexpected magnetic field. Unlike Venus and Mars, which have no global magnetic fields, Mercury generates a magnetic field about 1% as strong as Earth's. This discovery, made by NASA's Messenger mission, puzzled scientists because they didn't expect such a small, slowly rotating planet to maintain a magnetic dynamo. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, led a team that found something even more surprising about Mercury's magnetic field. They discovered that the field is offset from the planet's center by about 20% of Mercury's radius. This offset could be due to variations in the thickness of Mercury's crust, which affects how heat flows from the planet's interior. But the mysteries don't stop there. In 2020, scientists announced the discovery of volatile elements on Mercury's surface, including sulfur, potassium, and sodium. These elements typically evaporate quickly at high temperatures, so finding them on a planet so close to the Sun was unexpected. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory suggested that these volatile elements might have been delivered to Mercury by comets or asteroids after the planet formed. A fascinating recent discovery on Mercury is the presence of water ice in permanently shadowed craters near its poles. Dr. Nancy Chabot, whom we mentioned earlier, played a key role in this research. Despite Mercury's proximity to the Sun, these craters remain in constant shadow, keeping temperatures extremely low and allowing water ice to persist. But here's where it gets even more intriguing. Along with the water ice, scientists have uncovered signs of organic compounds in these same craters. These dark deposits could potentially be complex carbon-based molecules, possibly similar to those that may have contributed to the origin of life on Earth. Could Mercury, in spite of its harsh conditions, hold vital clues about the beginning of life in our solar system? Another remarkable secret of Mercury lies in its unexpected geological activity. For years, scientists believed Mercury was geologically dead. However, data from the Messenger mission revealed signs of relatively recent volcanic activity. Dr. David Rothery from the Open University in the UK spotted small, bright spots on the planet's surface, which appear to be volcanic vents. These features, known as hollows, suggest that Mercury might still be geologically active today. One of the most enigmatic aspects of Mercury is its chaotic terrain, a vast region of disordered hills and valleys near the South Pole. First observed by the Mariner 10 mission in the 1970s, this area spans about the size of Texas. Dr. Thomas Waters from the Smithsonian Institution theorizes that this terrain could have been shaped by massive earthquakes, driven by the tidal forces of the Sun as Mercury's orbit evolved. Recent research has uncovered some surprising insights into Mercury's composition. Dr. Amir Khan from the University of Zurich, using data from the Messenger mission, examined Mercury's internal structure. His team discovered that Mercury's core likely consists of a liquid outer layer and a solid inner core, similar to Earth's. However, Mercury's inner core is much larger in proportion compared to Earth's, which may account for some of its unique magnetic characteristics. These fascinating revelations challenge our understanding of planetary formation and evolution, highlighting that even within our own cosmic neighborhood, many mysteries remain unsolved. As we look forward to upcoming missions and discoveries, we can't help but wonder what other secrets lie beneath Mercury's cratered surface. Mercury's hidden depths, recent findings, and ongoing missions continue to uncover secrets beneath Mercury's surface, revealing that its subsurface is just as intriguing as its visible features. One of the most fascinating aspects is Mercury's core structure. Unlike Earth, where the solid inner core is surrounded by a liquid outer core, Mercury's core is mostly liquid with a solid inner section. This unusual composition was confirmed by NASA's MESSENGER mission, which mapped Mercury's internal structure using subtle variations in its gravitational field. The solid inner core of Mercury is estimated to be around 1,260 miles, 2,000 kilometers, wide, making up nearly half of the planet's core. This is significantly larger in proportion than Earth's inner core, which comprises only about 20% of our planet's core volume. The size and composition of Mercury's core play a crucial role in generating its magnetic field, which, although weaker than Earth's, is still surprisingly strong for such a small planet. Beneath Mercury's crust lies a mantle that is thinner than previously thought. Recent studies suggest that Mercury's mantle is only about 260 miles, 420 kilometers thick, compared to Earth's mantle, which measures about 1,800 miles, 2,900 kilometers, thick. This thinner mantle affects Mercury's geological activity and heat distribution. One of the most exciting discoveries about Mercury's subsurface came in 2012, when MESSENGER detected signs of ancient volcanic activity. The spacecraft identified shallow depressions known as hollows, which appear to have formed when volatile elements sublimated from the surface. These hollows indicate that Mercury's interior once contained more volatile elements than scientists had previously thought. In 2020, researchers using MESSENGER data made another groundbreaking discovery. They found evidence of a vast underground magma reservoir that existed in Mercury's distant past. This ancient magma ocean likely played a significant role in shaping Mercury's surface and internal structure. The existence of this magma ocean could help explain some of Mercury's distinctive surface features, such as the expansive smooth plains that cover much of its northern hemisphere. These plains, known as the northern volcanic plains, are believed to have formed from massive lava flows early in Mercury's history. However, one of the most surprising discoveries about Mercury's subsurface came in 2022. Researchers studying MESSENGER data found evidence of nitrogen trapped beneath the planet's surface. This nitrogen may be the remnant of an ancient atmosphere that was forced underground by Mercury's intense heat and solar radiation. The presence of subsurface nitrogen raises intriguing questions. Could Mercury once have had a more substantial atmosphere? What might this imply for its early climate and potential habitability? Another fascinating feature of Mercury's hidden depths is the presence of water ice in permanently shadowed craters near its poles. Although this ice is on the surface, it's protected from direct sunlight and preserved by the extreme cold in these shadowed areas. Recent studies suggest that some of this ice may be relatively recent, possibly deposited by comets or asteroids in the past tens of millions of years. These polar craters also contain dark deposits that could be organic compounds. These volatile materials might be the remnants of cometary or asteroidal impacts. The preservation of such organic compounds offers a unique opportunity to study the distribution of organic materials in the inner solar system. As we continue to delve into the mysteries of Mercury, new questions emerge. How has its internal structure changed over time? Are there other volatile elements or compounds hidden beneath its surface? And perhaps most intriguingly, what can Mercury's subsurface reveal about the early history of our solar system and the processes that shape the inner planets? These questions underscore the importance of ongoing exploration of Mercury. Every new discovery brings us closer to understanding this intriguing planet and provides valuable insights into planetary formation and evolution across the solar system. Looking ahead to future missions and breakthroughs, one thing is certain: Mercury, despite its small size and close proximity to the sun, has many secrets left to uncover. Its hidden depths may hold clues to its past and possibly the entire history of our solar system. Quite the journey, wouldn't you say? Share your thoughts on what we might find on Mercury in the near future. Could it be precious gems, or perhaps even signs of extraterrestrial life? If you enjoyed this video, be sure to hit that like button and subscribe to the channel so you never miss an update. Thanks for watching, and we'll catch you in the next one.